In this video, we want to work on the Jacobian matrix. So in the question, we have this system of the nonlinear, and we want to set up f's and Jacobian matrix. So for the setting up the f, we would say that this one is going to be equal to the, let's name it f1. So f1 is equal to the x1 over 3 x2 2 minus 55, and for this one, and let's name this one f2. F2 is equal to x1 x2 minus 12. So that's our f, like the functions that we would have for f. The next step is to find out our Jacobian matrix. For finding out the Jacobian matrix, we know that the equation for Jacobian is that so the partial derivative of the f1 respect to x1, right? And then partial derivative of f1 respect to x2. Here in the second row, we are going to deal with f2. So partial derivative of f2 respect to x1 and partial derivative of f2 respect to x2. So when we look at this one, it means that we need to find out these partial derivatives. So for partial derivative of the f1 respect to x1, so we want this is f1 respect to x1. When we are working, we want to find out the partial derivative of a function respect to a specific variable. We ignore the rest of the variables. We think that, okay, so the rest of the variables, they're just numbers. It's like we would, for example, here, the partial derivative of this function respect to x1 is like that. This x2, it's another 55, for example, yeah, or some numbers, 20. So it's like a number here for us. So we are going to have, we just need to get the derivative of this one. So it's going to be 3x1 squared. So that's going to be my partial derivative of f1 respect to x1. And the next one is the partial derivative of f1 respect to x2. So here, this one is going to be like a number or some constant. So we would have this one is going to be minus 2x2. The next row, we have the partial derivative of the f2 respect to x1. So this is the f2 respect to x1. So this x, we said that when we want to get the partial derivative respect to one variable, the next variable is going to be like constant. So it's like here it's going to be x2, right? And then the partial derivative of the f2 respect to x2. So it's like that this x2 is my variable, so this x1 is like a constant, so it's going to be x1. So my Jacobian matrix, as you see, is going to be 3x1 power 2 minus 2x2, and then here is x2 and x1. This is just for one, like we would have just f1 and f2, and we want to do the Jacobian matrix for this. Here, what you can do, if you would like, you can try to solve this Jacobian with the finite difference. Instead of getting the partial derivative with respect to x1 and x2, there is another video that we have which talks about the evaluation of the Jacobian through finite difference. So you can use the finite difference method to find out these partial derivatives, and then you can compare it with this, right, to see that what would be the difference.